The steering wheel in Formula One is a marvel of modern racing technology, a compact, ultralight interface packed with the brain power to control almost every aspect of a car, traveling at over 350 kilometers per hour. Imagine gripping a device that simultaneously manages gear shifts, engine power, hybrid energy deployment, aerodynamics, and direct communication with a full pit crew. This wheel fuses race strategy and split-second driver skill, turning milliseconds into deciding factors, and it's evolved dramatically lap by lap, season by season. Start by picturing the materials. Lightweight carbon fiber shapes the body of every wheel for relentless strength and featherweight agility, keeping mass under 1.5 kilograms. Titanium springs, copper wiring, gold electrical contacts, and shatterproof polycarbonate displays ensure the wheel functions lap after lap with zero delay no matter the G-forces. Suede or rubber grips eliminate slip, even with sweaty gloves, high vibration, and every bump of the track. Internally, silicone insulation protects vital circuits against heat and shocks. Those materials are just the foundation. The ergonomic design goes even deeper. Each wheel is custom molded to fit a driver's hands, allowing split-second muscle memory operation without distraction. Unique button icons, textured switches, and distinct contours mean that drivers can feel their way, even in the heat of battle, without a glance down. Now move to the control heart of the wheel. Today's F1 steering wheel is a command center, not just a turning tool. Most wheels sport 20 to 25 buttons, switches, rotary dials, and paddles, each serving a unique task. Let's break down those functions. Shift paddles enable lightning-fast gear changes, up to 50 in a single lap, without hands ever leaving the wheel. Below or behind those, clutch paddles allow for precise launch controls or slow-speed maneuvering. Then come the dials and toggles. Rotary switches fine-tune brake bias, adjusting the balance between front and rear axles based on corner or track conditions. 3 separate switches can control the differential for optimizing entry, apex, and exit grip, vital for tire management and cornering. At any moment, with just a thumb press, drivers trigger the drag reduction system (DRS), instantly reducing rear wing drag for top speeds on straights. Another button activates the pit lane speed limiter for safe entry. Engine mode selects balance raw power with fuel efficiency, shifting strategy for qualifying, overtaking, or endurance runs. All the while, a central digital display relays live telemetry, lap times, temperatures, sector gaps, warnings, or system statuses. 15 shift indicator LEDs above the display cue upshift timing for peak acceleration. Some buttons mark telemetry snapshots, sending coded signals to engineers for diagnostics or strategy changes, sometimes under full green flag racing, without slowing down. The radio button allows drivers to communicate directly with their team, while another controls onboard hydration systems. Safety is paramount. Mission-critical switches feature multi-step engagement or protective rims, reducing the risk of accidental activation. The design also leverages color coding, distinct button shapes, and tactile feedback, all to guarantee the right switch gets hit, even under heavy vibration, with gloves and around tight turns. Each team customizes the wheel layout. The shape, grip size, and even button placement can change from race to race, often based on a driver's feedback or a unique circuit's demands. Sometimes the grips and button arrangement are tweaked mid-season as drivers and engineers chase microscopic advantage. Building a wheel is a complex feat, up to 80 hours per device, involving mechanical designers, wiring specialists, and electronics experts. Main components, like the LCD display and the control circuit boards, come standard across teams for regulatory reasons, but everything else is custom-built and programmed. Every year, new features arrive. In the late 1980s, paddle shifters revolutionized gear changes. By the 1990s, LCD displays fed live data straight into the cockpit. The hybrid era added layers of complexity, making energy deployment, recovery modes, and battery management part of the driver's daily routine. Quick-release systems now enable emergency extraction, vital for safety. Training is relentless. F1 drivers spend hours on custom simulators, practicing switch changes by instinct. They rehearse emergency procedures, muscle memory drills, and even race starts for clutch engagement, getting every adaptation just right. The future promises even greater innovation. Haptic feedback and advanced digital overlays will push real-time data into drivers' hands with less distraction. Predictive AI and biometric sensors, currently in prototype, will track driver fatigue, stress, or reaction times mid-race, feeding strategy adjustments with unprecedented accuracy. Comparing an F1 steering wheel to a regular car's wheel is like matching a fighter jet's controls to a bicycle's handlebars. Standard road wheels offer a horn and maybe cruise control. The F1 wheel delivers up to 20 buttons, custom molded grip, real-time telemetry, and instant fit for extraction and safety. Ultimately, the Formula One steering wheel is proof of the sport's relentless quest for performance. It's not just about turning the car, it's about synchronizing man and machine at the absolute limit of speed, feedback, and control. Every lever, dial, and toggle can mean victory or defeat. This tiny, brilliant piece of racing hardware is a showcase for the world's best engineering, and an icon of what motorsport technology can become.